everybody. So in this video we're going to talk about what the trends are, and we're also going to discuss what the definitions of different types of properties for the atoms are. So the trends, what we're looking at is we're looking at how there are changes either across a period. So we're looking for changes across a period, or we're looking for changes down a group. So really, that's what we're looking for, those two things, either across a period or down a group. And so we're going to look at the trends of these following properties. Ionization energy. And ionization energy, what it's defined as really is the energy required to remove the last valence electron. Your book will use language like, the most loosely bound electron. Well, that's the valence electron. Now, we'll mainly be looking at the first ionization energy, but if we remove the second electron, we'll remove, the second one, and we'll have the second ionization energy. Those are called successive ionization energies. We'll do a slide on that a little bit later. Okay, electronegativity, that has a strange definition, and it is the attraction an atom has for electrons in a bond. And this is a made-up scale, and it's made up by a guy called Linus Pauling. And Linus Pauling, he came up with this scale to sort of cut out any of the inconsistencies that we see with ionization energy or something called electron affinity. He made up this scale to sort of get an overall rating for an element. How likely are you to gain, or how likely are you to attract electrons in a bond when you're with another element? Atomic radii, this is the distance between the nucleus and the valence electrons. A lot of times they'll do something called a bonding atomic radii, where they have two atoms bonded together, and they're able to measure the distance between the two nuclei and cut it in half, and that will give them an idea of the atomic radius. Okay, so let's talk about atomic radius. This is the distance, the size of the atom, basically. If we look at atomic radius, it really is about the size of the atom. So let's look at this trend going down a group. So if I go down a group, the radius is going to increase. Why would a radius increase going down a group? Well, let's look at group 1. Let's compare lithium. Lithium has its 3 protons and its 2 energy levels. And let's compare that to something like sodium. Sodium has its 11 protons and it has its 3 energy levels. So why would, sodium be larger than lithium? It's the number of energy levels. So when we go down a group, they ask why. It's because you have an increase in the number of principal energy levels. So as the number of principal energy levels increase, the electrons get further away from the nucleus. Sometimes they'll say the shielding increases. Remember, we talked about shielding last video, so the shielding will go up. What about across a period? And this one people might say, well, it increases too. You're adding more electrons. But it turns out that the radius actually does the opposite. The radius goes down. And if we look across a group here, if we look at lithium again and just copy and paste that one, move that over here, and then we compare it to something like fluorine. Fluorine has 9 protons, and it has the 2 energy levels. So why would fluorine actually get smaller? Well, let's look at the structure here. 3 positives in the nucleus for lithium, 9 positives in the nucleus for fluorine. Which one has a greater nuclear charge? That would be the fluorine. It has more protons. But the fluorine also has the same number of energy levels. So when I look at the Zeph the effective nuclear charges for lithium, I have 3 minus 2 inner electrons. I have a Zeph of +1. When I look at fluorines, I have a Zeph of 9 minus 2 inner electrons. I have a Zeph of +7. So if I were to put this into words, I would say the fluorine atom has a higher Zeph. That equals more attraction for its electrons. With that higher attraction, the electrons are pulled closer to the nucleus. So because of this, the atom gets smaller. So just to summarize this, we have the trend down a group. The radius is going up. That is because we have more principal energy levels, so this means a larger atom as you go down. And then going across, we have more effective nuclear charge, so we have more attraction. The electrons are getting pulled in more. Let's look at this in a picture format. If we go down a group here in green, we can see that the atom's getting larger. Here is the radius of both the ion and the atom. They're getting larger. Now, as we go across, if we do that in a different color, like pink, then we can see that going across, the atoms are actually getting smaller. Now you notice that they have numbers in red and blue, and those are the ion numbers. And those ions, like they are going to, they're going to be different. Either they're going to gain or lose electrons. And so, for example, if I ask you this question, and we'll discuss this in class on Monday when we have class together, compare lithium and lithium plus. And my question to you is, which is smaller? Which of those is smaller? How about this one, oxygen and oxygen 2 minus? And I could ask you the same question, which is smaller? So let's discuss that in class on Monday. We'll see what you come up with. You should have, which is smaller and also why. Why is it smaller? There's something else that I want to do with you, though, to finish this off, and that's isoelectronic series. And the isoelectronic series, it's looking like this. We have what the definition is. The definition is it's an atom / ion with the same number of electrons. And so when I look at an isoelectronic series, it will look like this. It'll be sodium plus. That has 10 electrons. Then I could have something like magnesium plus 2. That'll have 10 electrons. Aluminum plus 3. That'll have 10 electrons. If I shift these all over, I could have neon has 10 electrons. F minus has 10 electrons. O2 minus has 10 electrons. These are all isoelectronic. N3 minus has 10 electrons. Same number of electrons. The question I ask you about this one, I'm going to leave off here, is, well, order them. I want you to order them from smallest to largest. In class, we'll talk about these, and we'll take some notes on that stuff. My next video is going to be on ionization energy and the trends for that. Thanks so much for watching.